All right, so today we're looking at dividing rational numbers. And just like with multiplying rational numbers and adding and subtracting, there are two rules. And I put here in the notes, same as multiplication. It's the same as multiplication. So you're like, wait, what do you mean? What were the two rules for multiplication? The first rule related to like signs. When you have two numbers being multiplied with like signs, what's your product? Positive. So guess what? Your first rule with division, when you have two numbers being divided with like signs, your quotient is going to be positive. I'm not going to write all that out because you guys already have it for multiplication, but I can write it in this way. A positive divided by a positive is going to be a positive. Yeah. That's all right. I'll give you another chance on that. What about a negative divided by a negative? That's going to get me a positive. I think that's me. Okay. No, it's not me. So here's how we can summarize it. Like signs, positive result. Just to make it clear, like signs give me a positive result. So if you have two positives divided, positive answer. Two negatives divided, positive answer.
How do you spell quotient?
Q-U-O-T-I-E-N-T. Spelling. Quotient. Q-U-O-T-I-E-N-T. Quotient. Okay. I've never been in a spelling bee. I don't think I would do very well. I get very nervous in front of people, so. I know, it's weird. I don't want to spell in front of people.
You're a teacher.
Oh, yeah. Oops. Okay, so that's the first rule. The second rule is a positive divided by a negative should get me a? Negative. A positive divided by a negative should get me a negative quotient, negative result. And a negative divided by a positive should get me a? Negative result. So, unlike signs, negative result. Unlike signs, negative result. Okay, so the same rules as multiplication. If you know like signs being multiplied, positive. Unlike signs being multiplied, negative. It's the same for division. Why though? I always wonder why. And here's honestly what I used to think as a middle school math student. A teacher would put up rules like this, and I'd be like, okay, fine, negative or positive. But I never really understood the background why. I used to think that there were people, maybe in 2001, who got together, these mathematicians from all over the world, and they sat together around a table and they decided, you know what? What happens if you multiply two like signs? And some said, that's positive, and others said, no, that's negative. They were fighting and discussing it. They had their lunch. Then they came back, a little bit more easy to deal with, and they said, you know what? Like signs, when you multiply them, let's just do positive. Yeah, positive. Yeah, we got it. Doesn't it feel sometimes that things were just made up?
Yeah.
Do you guys ever feel that way? I agree. It feels made up. But is it made up? And the answer to that is no. It naturally falls. Okay, cool. That's a great question, Kate. Very good question. Let me just go to this, and then we'll go to that broader question. Do you guys remember that multiplying can be checked by dividing, and dividing can be checked by? Do you guys agree with that?
Yes.
Okay, so I'm going to go back to this first rule. And this is a number divided by a number equals a number. So blah divided by blah equals blah. Easy enough, right? How can you check this division problem? I do a positive times a positive would have gotten me a positive. Oh, that follows that rule from Friday. What about a positive times a negative? Negative. Huh. That follows that rule too. Let's see if it follows on these. What's a negative times a negative? Positive. Whoa. What about a negative times a positive?
A negative.
Whoa. That works every time. Guys, it works every time. It was made up. So, Kaden, you had a great question. Where did that all come up?
Yeah. I don't know.
When mathematicians, when you read the history of math, and you're like, why would I ever read the history of math? Because it's interesting. But when you read about the history of math, this is what you read about. So-and-so, the Greeks, the Egyptians, the English, the Germans, this is the key word, discovered. Discovered. What does it mean to discover? Yes, ma'am? Yes, come here.
So, like, find something that's already there.
It's find something that's over there. So if I come here and I look at Sammy's notes and I see that there are 2 rules for dividing. Did I come up with those rules or did I uncover what the rules were? I uncovered. So guys, these things are naturally what's happening. People just discover them. They find out, oh wow, this is what happens. So where did that come from? Like who left it? Who left it behind?
Jesus.
The Lord himself. And guys, listen to me very quickly. I know that seems like, yeah, you can just say everything and say Jesus or God, but this is actually where it all ties together. See, where did math come from? It came directly from God himself. Because how did he create the world? With wisdom. Right? Do you think he created with wisdom? Just look at your body, what it can do. You're going to eat a Jersey Mike's sub today, some of you. And that sub is going to break apart scientifically and mathematically to give you energy for the day, for the hour, whatever. Depending on which one you got. Steak and cheese, anyone?
Oh, yes.
Good choice. Okay, anyway. Ham and cheese? Turkey and cheese?
I
Okay.
had that, yes, hot.
God allowed that food to give you energy in a way, guys, that you can study the digestive process and you get really nitty gritty. It's like, what? On the cellular level, things are happening. But you can also describe that stuff with math. And it's like, are you kidding me? It's really deep, guys. I don't expect you to know, but I do expect you to know this. Somebody planned it all. And that person is the Lord himself. And you can say that Jesus did it because in Colossians it says, by Christ, Jesus Christ, everything was made that is made, which is really cool. Anyway, sorry. What are you getting to learn about in math class then? Who are you getting to learn about? God himself. Okay. I have one more thing here to go on. There are some key words in math, especially with division problems, that I really want you to get. Dividend, divisor, quotient. How many of you know those 3 words? Dividend, divisor, quotient. Okay, ready? Here's a division problem. This number is called the dividend. The second number is called the divisor. And then this result is called a quotient. And you're like, who cares? You can just call it the first, second, the third, or the answer, or the other numbers. Well, here's what you're going to learn in Algebra 1. Here's one reason why. The quotient rule for exponents. You're like, huh? What are exponents? I think you guys would know what those are. Quotient, what's going on with those exponents? They're being divided. That's what it means. And you're like, huh? At least you would know it's some kind of division and some kind of quotient, some kind of exponents, and then you come up with that rule. So you do need to know the terms. And I will quiz you throughout this lesson. Oh, your first problem, because I'm done talking about all this background info. It's time to get into the problems themselves. We're going to do some division with fractions and decimals, and we'll start off with some decimals. Now, I'm going to, again, review this with you guys. What's a negative divided by a negative? Oh.
Positive.
Automatically positive. In fact, if it's a positive result, I don't have to worry about signs anymore. I'm not putting these signs in my work. I'm done. I got positive. Which, you don't have to, but I do it just to make it clear. I know my answer is going to be positive. So which one of these numbers goes in the division box? Yes, ma'am?
The 4.
Yes, it starts with a 4. She's good. I'll give you another chance.
Negative 49.
It's the 49.2. 49.2. The dividend always goes in the box. Dividend always. But Mr. Ray, what if the dividend is smaller than the divisor? Doesn't matter. You put that number in the box. The first number always goes in the box. The dividend always goes in the box. Which number always goes in the box?
The dividend or the first number.
Awesome. And you can think of it either way. Okay, so that means the divisor goes outside. Mr. Ray, where are your positive and negative signs? Do I need them anymore?
No.
Because I know my answer is positive, so I'm just going to divide it out. But I can't do it this way. What do I have to do, Aiden?
I was going to volunteer for the answer.
Okay, I need someone to help me. Like, what do I do? Because I'm like, I think I could do that. Maybe not. Jimbo?
So what I'd do is I'd act like it was a normal division problem, like 4
492 divided by 41.
Because you cannot have what kind of number as a divisor? Decimal. So I'm going to move it once on each. And one in the other class gave me a great pointer because a lot of times if we start working this out, we get mixed up. They move the decimal point and they rewrite that problem.
I just erased it.
And that's okay, yeah. Just make sure that it's super clear that your decimal point is not there. It should be over here. Okay, 41 goes into 49. One time. Then I subtract, I get a remainder of 8. Bring down the 2. 41 goes into 82 twice. Oh, you should be thankful that this problem ends and doesn't keep going, right? Because problems could keep going. This one ends. My answer is not, my answer is not negative 12, positive 12. So again, you don't have to write the positive, but I'm putting it there for emphasis. Okay.
Is it okay if you do write that?
Yeah, I can put positive 12 because we know she means positive 12. I mean positive 12. All right, just when you thought, that's not too bad, right?
Fractions.
Good call. Okay. In fact, not only just fractions, but mixed numbers thrown in there. All right, guys. Boys doing okay?
Yes.
Okay. What I want to give you a heads up on is when you have mixed numbers and or fractions, make sure that you're dealing with fractions. So can I change this 2.5 into just like fraction? Yeah, turn it into an improper fraction. 2 times 2 plus 1?
5/2.
5/2, and I'm just going to rewrite it. Okay. Now, do you notice that I have that problem written on the board over here on the whiteboard? Okay, the reason I do it is because I wanted to ask this important question, and anyone can answer it right now. What is division? What does it mean? Like, what does it mean? I know you know how to do it, but what does your answer mean in relation to those two numbers? Caroline, what do you think?
Division is like how many times a certain number goes into another certain number.
Okay. This question right here is asking how many groups of 5/6 can fit into 2.5? Huh? Okay. Yes, you want to add or change? Oh.
You might say.
Okay, yeah.
Find the opposite.
What is that? What is this new thing you speak of? Oh, stay, change, flip.
No, it's stay, change, flip, because it's division, people.
Stay, change. Write this down if you need it. Stay, change, flip. Now, when you divide, Camille just brought up something. You got to be kidding me. When you divide, it's like multiplying the reciprocal. Oh, I came up with a big word here. Reciprocal. Okay. How many of you know what it means to flip a fraction? Can you show me? Can you guys show me? A lot of people do this. Show me how to flip a fraction. Ooh, it's kind of fun. It's kind of fun. Okay. So that flip, guys, is a nice way to do this. But why do we flip? Because we're thinking of this word. Reciprocal. Reciprocal is an important word, not only in math, but also in life. Reese is so kind to me today. He sees I didn't bring a lunch, so he gives me part of his lunch or all of his lunch. That's a kind thing to do. And then tomorrow, maybe he forgot, or next week or next month, and I reciprocate by giving him part or all of my lunch. Do you heard of reciprocating? Okay, that's a positive thing. A lot of people unfortunately do a negative thing, which is also known as revenge. Okay, so you could reciprocate in a kind way, right? Can I have part of your lunch? Just a dessert.
The dessert.
I think he's saying, I think that means, oh my. I think he means that's a good thing. Okay, anyway, but you can reciprocate and you can reciprocate in fractions. Yep.
Okay, so I've heard like so many terms when I was younger, like people reciprocate money to people. Like, and I never knew what that meant. So that's like if you owe someone money, you reciprocate it to them.
Yeah, you're kind of reciprocating. Like you give me money, I reciprocate, give you money. Yeah, so we're going back and forth. So we're just flipping back and forth here. That's what we mean by stay, change, flip. And if you boys are having trouble, I will fix that problem very quickly. Okay, so how do I do stay, change, flip with this problem? Well, I will do this. Stay. What do I change the division problem to?
Multiplication.
Good. And then I flip 6/5. So I got 5/6 flips, 6/5. And do you guys remember what I could do with, by the way, guys, this was Friday. From here on out, we already did this stuff. But what can I do to this problem to make it slightly easier to work out, Tyler?
Oh, you can
What do you call it? I need the correct word because a lot of people mix up. What's the correct word?
I don't know.
Kansas.
Cancel. Good job, Tyler. Cancel.
Yeah.
What can you cancel? Go ahead.
You can cancel out 2 and 3.
Oh, sorry, the 2 and the 6?
2, yeah. 2.
So 2 goes into 2 once, 2 goes into 6 3 times. Good.
And then 5 and the 5 and then become 1.
5 goes into 5 once, 5 goes into 1. And here's your multiplication problem. Ready? 1 times 3.
3.
1 times 1.
1. 3.
So 3 over 1 is?
1. 3.
All right, let's see. Positive or negative?
Positive.
You look at the original problem. Positive, divide by positive, positive. Okay, do you really understand the answer? Here's what it means.
No.
How many groups of 5, 6 can fit into 2.5? 3. You're like, what does that mean? Okay, what I'm going to do is I'm going to show you a little diagram right here. And I want you guys to please pay attention because some of you, you look at the diagram, you're going to be like, that's what you meant. And some of you are going to look at it and say, I have questions now. And some of you are going to look at it,
Meh.
no response. Okay. You weren't looking, you're kind of staring out there. Okay, ready guys? You don't have to draw this out, but I'm going to draw 2.5. So here's 1, here's 2, and here's 3. Now I'm going to divide them into 6. 1, 2, 3. Okay, 6. I'll do a little bit. Oh, not perfectly, but
The first one was.
the first one was much better. Oh, okay. Guys, do you guys agree that 2.5, this is 1, this is 2, and then a half, right? You guys okay with that? This is the important part. Do you guys see 2.5? Okay, I want to see how many groups of 5, 6 can fit into 2.5, so this is what I'm going to do. This is where you need to pay attention. Okay, would you guys agree that this is 3, 6? Like this right here is 3, 6. Would you agree that's 2, 6?
Yes.
Okay, so if I took them all together, I would have 5, 6, right? Well, a group of 5, 6. Here's another group of 5, 6 right here. You guys get that? 1, 2, 3, 4, 5. And here's a third group of 5, 6.
What about the white thingy?
The white space is just empty space.
No, white space.
Oh, this one, remember, we started off with 2.5, so technically you didn't have this, right? It is there, but it wasn't filled in. So how many groups of 5, 6 are in 2.5? 1, 2, 3. Right? That's what you're answering in division problems. How many groups of this are in this first number? How many groups of the divisor are in the dividend? And there are 3. And that's exactly what we got. Mathematics. I hope some of you got that. Yes, ma'am.
So what happens if when you're doing your division and you get like it never ends? Like,
Oh,
how
okay.
would you do that?
Yeah, it could either. So you're not going to get those things, Caden. If it keeps going, guys, and never ends, you did something wrong. Yeah, something went wrong. So I would go like after 3 digits, you're like, it's not ending. It doesn't look like it's going to end. Stop. Go back. Something went wrong.
Okay.
But if it did repeat, you just pull a little bar.
We're not gonna get any problems like the division doesn't end.
Did I? Can I say no? Can I say no comment?
No.
Yeah, no comment.
How about this?
Oh,
Let's-
that just means dividing.
Oh, what? This looks up here, guys, like a messed up fraction. It looks like someone wrote a fraction and forgot to use some integers.
Dividing.
That's what I just.
What? Oh, today's lesson is dividing. I'm so sorry. Okay, yes. Guys, a fraction means dividing. So you have to divide this problem. And you're like, what do you mean divide this problem? It's negative 0.0168 divided by negative 5.6. That's what this is the problem. So a fraction bar, oh wait, they're the same thing. This is a fraction bar, this is a division bar. So I divide. Okay, but it's a negative divided by a negative.
Positive.
Oh, positive. Wow, okay. Which number goes in the box?
The first one, the dividend.
The dividend. So I'm not going to put the negative sign anymore because I already know my answer is going to be yes, positive. Okay, and then the divisor goes out. Can't work it out this way, so I got to move the decimal point once in both numbers. I'm going to rewrite it for my own sake and for the sake of you. And you know what? You can erase. Yep, you can erase. But I want to show you my steps. Bring the decimal point up.
Wait,
All
why are
right.
there now only ones?
Because you don't need to.
Oh yeah, because you could have put 0.168. Like that's technically right, but you really only need one before a
Do
decimal
you
point.
need any zero?
You don't have to have it. Nope.
So it could just be 168.
0.168. Yes, 0.168. All right. How many times does 56 go into 0?
Zero.
Into 1.
Oh, that's interesting.
Into 16. Into 168.
3.
Exactly 3 times. All right. So my answer. How do you say this technically? How do you say this number technically, properly? Yes, Ruth. 3.
0 and 3,000.
Okay. You could say 3 thousandths.
And
Yes, ma'am.
I have something else. A way to remember a fraction bar is also a division bar.
Mm-hmm.
Because if you look at the little division symbol,
Look.
it looks like a fraction.
No
Like
way.
a dot and then a line and then a dot.
Okay. Now, Ruth. I think you came up with something here that Ruth. That is a fraction bar, and that kind of looks like something should be on top and below. Now, actually, you know what, Ruth? I need you to do us a favor. Can you look for the origin of that sign tonight and give it back to us tomorrow?
More homework, Ruth.
She's doing this in her heart. Can you do that, Ruth? Because I think you're right, but I want to make sure. Because I'm like, I never thought of
Did
that.
you know the ifs?
I don't know. I don't know where this little symbol came from. I think it is that.
Wait, is she gonna go look up what is the division symbol?
Where did the division symbol come from? Or why is the division symbol the way it is? You can Google whatever. Yeah, you can search it out. Yes, ma'am. That's a good question. I think that's it.
Well, at least on this problem that I remember that's like the thousandths because some people
Oh,
like if you put like a 0 point, it looks like 3,000 backwards.
yeah, and that actually with that 0, if you read it backwards, it would be 3,000. And so you just put that THS, 3,000. Emphasis on the. Colin, I have an important question for you.
Yes.
How many groups of, and you don't even have to think of the negatives, but how many groups of 5.6 can fit into 0.0168?
3,000.
3,000. You're like, how is that even possible? Listen to me, guys. Come on, stay with me.
I'm listening.
That means, guys, you cannot even fit a whole one of these groups into here. You can't fit a bigger number into a smaller number, right? So how much of this bigger number can you fit? Only 3,000ths of it.
That's like super tiny.
Super tiny. Yes,
Like
3,000ths.
How small?
Like, I don't know. No, it depends on what you're talking about. Like, are you talking about like 3,000ths of a room?
Of a
Or
pizza.
3,000 of pizza?
Yeah, pizza.
Pepperoni?
I'm hungry.
Pineapple?
Sausage.
No.
Pineapple.
Yes, bonus points. Pepperoni and pineapple. If you haven't tried it, you cannot say anything about it. You gotta try it.
What if you don't like pepperoni pizza or pineapple pizza? So you won't like either. Sweet.
But maybe together they bond.
I'll try it.
Sorry, I got a lot. Wait, what are we doing? Lunch, pizza. 3,000. Yeah, it's a very tiny sliver. Very, very tiny sliver of it. Okay, go ahead and do this one, guys. I want to see if you really understand what we're doing with division.
Sammy, why?
Here's your division problem, guys. Positive or negative answer?
Negative.
Negative. So don't worry about the signs anymore. Just it's a negative answer. Just deal with the numbers. Let me see if you guys understand the problem. How many of these groups? How many of these groups can you fit into 3? How many of these groups can you fit into 3? Can you guys imagine a lot or a little?
A lot.
A lot. I could fit quite a few of these groups into there. And you're like, how many? Let's find out. Let's find out. Okay, which number goes inside the division bar?
3.
I thought, yes, it's always the dividend. And therefore, I'll put 0.0. Oh, wow. If I can write this number, that'd be great. 0.075. Okay, I can't do that the way it's written. 1, 2, 3. 1, 2, 3. So I'm really seeing 75 into, oh man, 3,000. Speaking of 3,000, that's a big number. 75 does not go into 3. It doesn't go into 30, but it does go into 300.
5 times.
4 times. Yay, my answer's 4. No. Oh, man. Negative 4.
40.
40. Guys, it's 4, right? But there's a place value waiting to be filled.
How many times?
40.
That's trying to be something of like from 3rd grade.
How many? Yeah.
In our teacher.
How many times can this number fit into this number?
-4.
40 times. Oh, nice. Yeah, -4 because of the negative and negative. Yes. Which really means, by the way, negative doesn't mean like bad. It just means like, for example, debt. Like if you have this many times of debt, okay, that's a negative value. Or below sea level, right? You say positive above, negative below. That's not bad, it's just below. Temperature, same thing. Yes, ma'am. It can be if you owe it, if you owe the debt, it could be a bad thing. It doesn't always have to be. But if someone owes you debt, that's a positive. That's a good thing. Oh, Henry, you said that too happily right there. Okay. Oh my. All right. Next problem. Go ahead and do this one here, guys. Back to fractions. We're going back and forth, back and forth. And I need a lucky volunteer, a volunteer to come up here and do. It slipped.
I'll do it.
Dalen, come on up and do this problem. Everyone else, work it out. Oh, he is. He's recording it all. I just don't want him to follow me because I move too much. I want him to come back here as I'm right here, and then he sees all of you. It's like, you have an answer? Question. Go ahead. Oh, a specific question. Okay, good. She says it's going to be positive, and she's done with her signs.
Since it goes to 1, would I exit out and do the 1, or would I just do
Yeah, because right here with these two. Yeah, how many times does 5 go into 5? Once? And then 5 goes into 20 4 times, so you just leave it like that. And then what about 3 and 3? Yep. And then, yeah, now you do 1 times 4, 1 times 1.
Got it.
Possibly.
Miss Red.
Now, Dalen, to save you some time, what if you canceled before you multiplied? So here, I'll just do this real quick. Like that. Okay. Because it'll make it easier to simplify.
Can I do the next problem?
It's possible.
It's possible I play the next problem.
It is possible. It's not beyond the realm of possibility. All right, so she got an answer of +4. Is that correct? Yes. How many groups of 3/20ths can fit into 3/5? 4. That's what you're saying. Remember, stay, change, flip. So make sure you do that. All right, guys. Speaking of messed up fractions.
Are you kidding? No.
How does that even go?
Wait, can you make it infinite? Like an infinite amount of fractions? Like you just like.
How about this? Let me answer that question. Okay, this guys looks like someone messed up their fraction. They just confused something and they're like way off. Okay, we call this a complex fraction. The reason we call it a complex fraction is because I have more than one fraction bar in the problem, right? Fraction bar, right? Don't worry. In today's lesson, you'll have up to 3 fraction bars in one number. But in Algebra 2, you might have 5 or 7 of them. So you don't worry about that until next year, possibly. Okay, this is a division problem.
You could have like 1,000.
You could, yes. It would be very complicated, but you could, yes.
And then you could have to solve it.
You could simplify, yeah. Okay, guys, this is a division problem. What is it? What's the division problem? Chris. Yeah, read it to me as a division problem. Negative. Or yeah, 3 1/3. Yep, that's the problem. That's all you have to do. If you have a complex fraction with a number over a fraction or a mixed number, and you'll see the next problem, you just rewrite it. You want to work it out?
Sure.
Oh. Yeah, come on, Mary Addison, work this one out, please. Carefully, I want to see your work, and then Chris will help you out. Everyone should be working it out. Everyone work that problem out right there. Hopefully get a good answer.
Turn it into a fraction.
There you go. Yes, sir.
So, that would be right? Because I changed. I didn't stay changed for. I did.
Oh, is it this one?
Yeah.
Okay, sorry.
And I changed it into
But, so you gotta keep it in order. So you're gonna do negative 80 first, then 3 1/3 first. Yes. So it's gonna be 80 over 1 times 10, 3 over 10. 80 over 1 times 3. Okay, let me help you out. I'll write it down the way. So it's really 80 divided by 3 1/3, right? So you do first change them into both improper, then do state change flip. Oh, nice. Thank you for the verbiage. All right, listen up, guys. How many groups of 3 1/3 can you fit into 80? 24 of them, right? 24 of them. This is how we did it. Listen up. You change these both into improper fractions. And do you remember on the first lesson of this chapter, on the first lesson I said this, can you change 80 into a fraction? Do you remember me asking you that? Something like that? You just say 80 over 1. Okay, and then 3 1/3 is 10/3. So here's the division problem still. Stay, change, flip would turn into this. She canceled out. Oh, I'm so thankful you canceled those out. Because if you don't cancel it now, you have to reduce it later, which is not hard, but it is an extra step. And yes, it is negative because a negative divided by positive is always negative. And this time, yeah, negative 24. All right.
I flipped both of them.
Yeah, only flip one of them, and it's always the divisor, the second number.
And I also have it in the row. So
Yeah, so be careful now.
did do it that way.
Audrey, why don't you come on down? You are the next contestant on Math is Right.
Can I have that one? Math is what?
Right.
Mr. Ray, can I have next?
Math is that.
It's like the math is right.
Okay, you show your work so we can understand what's going on. Everyone else work it out. Possibly. Yeah, I can't promise anybody, but there is a possibility.
Audrey,
So Audrey and everyone else, this is a complex fraction because how many fraction bars does it have? 3, or we could say more than 1. But it's also a division problem. And by the way, guys, once you get these complex fractions into division problems, then it's like, oh, this is familiar territory. So go ahead and work it out, please.
Wait, Mr. Ray.
Yes, ma'am.
7 total over 25.
Yeah, so you can't cancel that. So
5 over 14.
And then you have to change that into a mixed number.
14? Oh.
Yeah, I know, I did that.
Wait, can I seriously please do a problem?
Say it again. It's, yeah. It's a lot. What do you want more? I know, I'm sorry, Sam, but thank you for trying to do it, because that's cool. You can do one from your homework on the board. Oh, it doesn't help anymore.
Wow, this is like the most annoying problem ever.
Okay, so here's what I'm going to do. Now, this is correct up to this point, but big numbers, right? It's like, I wish they were smaller. Look at the fractions. 25 over 4. Can you simplify that anymore? No. 6 over 7? Nah. 25 over 7? No. What about 6 and 4? Simplify or cancel those out, then see what happens.
Supposed to be 7, 6.
Yeah, but remember, stay, change, flip. So you're good, you're good. So what goes in?
I'm not really good at that.
That's okay. What goes into 6 and 4 evenly? 2. So 2 goes into 4 twice. You write a 2. 2 goes into 6 3 times. Now you can multiply. It just makes the number smaller. And there you go.
No, they're mine.
So the numbers aren't simple, but they are easier, which is helpful. Yeah, there you go. What time do you have? Henry?
It is 11:15.
Oh, yeah, it goes up to like 5 times.
Yeah, like I was thinking 5. Whenever I'm feeling like 14s, 15s, 16s, I always go straight to a watch.
Really? That's cool. I'm just helping just so you can get it. So it's 5 times that with a remainder. So find out the remainder. All right, guys, listen carefully. 7th graders, some of you are done, some of you are still talking. I'm not listening to talking without permission. Okay, just to help you guys out. So listen, when you have a complex fraction, you're thinking, man, that's impossible to deal with. But you already know what fractions are. They're just division problems. You set up as a division problem, and then you get your final answer. It's going to be 5 and 5/14ths if you just left it as a mixed number. 5 and 5/14ths. Oh, I can look at the problem. I'll look at it. So yeah, you don't have to turn it into a decimal because that might be a longer decimal. So I'll take this. Thank you, Audrey. It's a hard problem. I gave you a tough problem.
I know what we're doing now.
All right, guys. This is your homework. 2 to 24 even. But then you also do numbers 48 and 49. Okay, they're just separate problems.
48.
Yes, do 48 and 49. But go ahead and get started.
Wait, so just 48 and 49. 24 even plus 48 and 49. Are the 48 and 49 the like?
Say it again.
Are the 48 and 49 like complex fractions?
No, they're just 2-step problems. Listen up, just a little helpful reminder of how the homework is written up here. Some of you get it, some of you don't. This little symbol right here, this dash, 2 through 24 even. A comma means and. So 2 through 24 even and 48 and 49. Just so you guys are aware.
Why do you cry like that? You're like,
All right, go ahead and get started, guys. Bye-bye, Swivl.